The Sun. Our Sun is the nearest star and the largest object in the solar system. The estimated age of Sun is about 4.5 billion years. It is a hot glowing ball of hydrogen and helium gases. The distance to the Sun from the Earth is about 150 million kilometers and is the source of energy for our solar system. Without the solar energy, the life on Earth, as we know, can not exist. The gravity of the Sun holds all the objects of the solar system together. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. At this temperature, a process called nuclear fusion takes place in the core which powers the Sun. The visible surface of the Sun, known as photosphere, is relatively cool and has temperature of about 5500 degrees Celsius. Why study Sun? The Sun is the nearest star and therefore can be studied in much more detail as compared to other stars. By studying the Sun we can learn much more about stars in our Milky Way as well as about stars in various other galaxies. The Sun is a very dynamic star that extends much beyond what we see. It shows several eruptive phenomena and releases immense amount of energy in the solar system. If such explosive solar phenomena is directed towards the Earth, it could cause various types of disturbances in the near Earth space environment. Various spacecraft communication systems are prone to such disturbances, and therefore an early warning of such events is important for taking corrective measures beforehand. In addition to these, if an astronaut is directly exposed to such explosive phenomena, she would be in danger. The various thermal and magnetic phenomena on the Sun are of extreme nature. Thus, the Sun also provides a good natural laboratory to understand those phenomena which cannot be directly studied in the lab. The space weather. The Sun constantly influences the Earth with radiation, heat and constant flow of particles and magnetic fields. The constant flow of particles from the Sun is known as solar wind and are mostly composed of high-energy protons. The solar wind fills nearly all the space of the known solar system. Along with the solar wind, the solar magnetic field also fill the solar system. The solar wind, along with other explosive eruptive solar events like coronal mass ejection (CME), affects the nature of space. During such events, the nature of magnetic field and charge particle environment near to the planet change. In case of the Earth, the interaction of Earth magnetic field with the field carried by CME can trigger a magnetic disturbance near the Earth. Such events can affect the functioning of space assets. Space weather refers to changing environmental conditions in space in the vicinity of Earth and other planets. We use more and more technology in space, as understanding space weather is very important. Also, understanding near Earth space weather sheds light on the behavior of space weather of other planets. About Aditya L1. Aditya L1 is the first space-based observatory-class Indian solar mission to study the Sun. The spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1, L1, of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any occultation eclipse. This will provide a greater advantage of observing the solar activities continuously. The spacecraft carries 7 payloads to observe the photosphere, chromosphere, and the outermost layers of the Sun, the corona, using electromagnetic and particle detectors. Using the special vantage point of L1, 4 payloads directly view the Sun, and the remaining 3 payloads carry out in situ studies of particles and fields at the Lagrange point L1. The suite of Aditya L1 payloads are expected to provide most crucial information to understand the problems of coronal heating, coronal mass ejection, pre-flare, and flare activities, and their characteristics, dynamics of space, weather, study of the propagation of particles and fields in the interplanetary medium etc. Aditya L1 Mission, the first observatory-class space-based solar mission from India. Major science objectives: understanding the coronal heating and solar wind acceleration, understanding initiation of coronal mass ejection (CME) flares and near-Earth space weather, to understand coupling and dynamics of the solar atmosphere, to understand solar wind distribution and temperature anisotropy. Uniqueness of the mission: first time spatially resolved solar disk in the near UV band. CME dynamics close to the solar disk from 1.05 solar radius, and thereby providing information in the acceleration regime of CME which is not observed consistently. Onboard intelligence to detect CMEs and solar flares for optimized observations and data volume. Directional and energy anisotropy of solar wind using multi-direction observations. The Aditya L1 mission will be launched by ISRO PSLV rocket from Satish Dhawan Space Center Shah, SDSC Shah, Sriharikota. Initially the spacecraft will be placed in a low Earth orbit. Subsequently, the orbit will be made more elliptical and later the spacecraft will be launched towards the Lagrange point L1 by using onboard propulsion. As the spacecraft travels towards L1, it will exit the Earth's gravitational sphere of influence. So, after exit from SO1, the cruise phase will start and subsequently, the spacecraft will be injected into a large halo orbit around L1. The total travel time from launch to L1 would take about 4 months for Aditya L1. The trajectory of Aditya L1 mission is shown in the figure above. Why study Sun from space? The Sun emits radiation, light in nearly all wavelengths along with various energetic particles in magnetic field. The atmosphere of the Earth as well as its magnetic field acts as a protective shield and blocks a number of harmful wavelength radiations including particles and fields. As various radiations don't reach the surface of the Earth, the instruments from the Earth will not be able to detect such radiation, and solar studies based on these radiations could not be carried out. However, such studies can be carried out by making observations from outside the Earth atmosphere, i.e., from space. Similarly, to understand how the solar wind particles and magnetic field from the Sun travel through the interplanetary space, measurements are to be performed from a point which is far away from the influence of the Earth's magnetic field. Is Aditya L1 a complete mission to study the Sun? The obvious answer is a no, which is not only true for Aditya L1 but in general for any space mission. The reason is that due to the limited mass, power and volume of the spacecraft that carries the scientific payloads in space, only a limited set of instruments with limited capacity can be sent on board the spacecraft. In case of Aditya L1, all the measurements will be made from the Lagrange point L1. As an example, the various phenomena of the Sun are multi-directional and therefore the directional distribution of energy of explosive, eruptive phenomena will not be possible to study with Aditya L1 alone. Another Lagrange point known as L5 is a good vantage point for studying the Earth-directed CME events and assessing the space weather. Also, the polar regions of the Sun are not well studied due to technological challenges of achieving spacecraft orbits for such studies. The Sun polar dynamics and magnetic fields are believed to play important role in deriving the solar cycles. Further, the polarization measurements of solar radiations at different wavelengths are required to understand the various processes occurring in and around the Sun.